this is a sine and cosine law problem. So basically we're going to solve for triangles. So I'm just going to sketch my 52 degrees, something like that. This is 34. Sorry, that's angle A. So side B is the one next to it, and side A is going to be 34 like that. Okay, so this is angle B, angle C, side C. Now, this happens to be an angle side-side problem, so we have to solve both possible triangles. Okay, so the other triangle that's possible with this is we have 40 degrees. It could be 34 in this direction and still generate our 50 degrees here. That's still A. That'll be B2, C2, and C2 here. Okay, that implies that this is B1, C1, side C1. So now I have two triangles to solve for. Okay, this does involve the sine law since I have an angle opposite side pairing that's known. So I have a known sine law ratio. So it allows me to solve for the unknown sides. So I'm going to write the ratio, the unknown B1, and the ratio is equal to sine 52 over 34, the known ratio. Okay, I'm just going to highlight that again. That is my known ratio. So solving for sine, first of all, I'm going to solve for sine of B1. Okay, and again, I need my calculator here since this is not exact values. Okay, so I'm going to do sine 52 times 40 divided by 34, and I get 0.927. So angle B1 is equal to 67.98 degrees. Okay, so this angle in here is 67.98 degrees. And the way I've drawn it, this is theta 1. This angle in here is a supplement to that, okay, because we know that as we make our isosceles triangle, this angle in here represents B2. So if I subtract from 180, I end up with B2. My angle B2 is equal to 112.02 degrees. Okay, so that's 112.02 degrees. Solving for C2, angle C2, I'm going to subtract from 180. 180 minus 112.02 minus the 52 degrees that was given. I end up with 15.98 degrees. So now I've got the two angles that I need. I just need to find my third side here. For C1, angle C1, we do the same thing. 180 minus 52 minus 67.98, and that gives us 60.02 degrees. Okay, so that's going to be 60.02 degrees, and we deduce that from 180 degrees. So the last part here then is to solve for the length of C1. So I'm going to use my known ratio and have my unknown side. So this is going to be 34 to sine of 52 degrees. Okay, so that's solving for C1. So 60.02, the sine of it, times 34 divided by sine of 52 gives me a length of 37.37. That looks about right given those angles, because it's kind of, not that far off of isosceles. Okay, so just going to highlight the 3 parts that I had to solve for in this triangle. Okay, I'm going to do the same thing over here. I'm going to solve for my unknown C2. Pair up this opposite angle, 15.98 degrees. Okay, and that's going to be equal to the known ratio of 34 to sine 52. Okay, and then solving for C2, okay, I get 15.98 times 34 divided by sine 52. Okay, so here I get 11.878, so I'm going to round that to 88. So that length here is 11.88. That looks pretty right. That looks fairly accurate based on that diagram. Okay, and not that the diagram is going to always be proportional, but we should always kind of think are the results that I'm getting, are they reasonable? Okay.